Hello everyone, this is Nityanjali from Sri Venkateswara College of Engineering, Bengaluru, from the Department of Electronics and Communication. Subject is Mathematics and
Areas of curvature of polar curves. The curvature is the concept in geometry that indicates the change in direction of the curve at a certain point. While the radius of curvature gives the radius of approximate circle that matches the curve at a particular point. In this article, we are discussing the radius of curvature along with its derivations and some of practice numerical. What is radius of curvature? The radius of curvature gives that extent of bend in the curve at a certain point, which is equal to the reciprocal of curvature k. Rho is equals to 1 by k, where rho is equals to radius of curvature and k is equals to curvature. Polar forms. The curves shown in the above figure are expressed in a polar form. As r is equals to f of theta, the line OX represented in the initial line and OP is the radius vector that touches the curve at point P and makes an angle of theta with the initial line. We can observe this in the diagram. At the tangent PT drawn to the curve makes an angle of psi with an initial line and it makes an angle phi with the radius vector. The angle psi in the above figure can be written as psi is equals to theta plus phi. By differentiating it with respect to s, we get d by ds of psi is equals to d by ds into theta plus phi. D psi by ds is equals to theta by ds and d phi by ds. D psi by ds is equals to d theta and d by ds plus d phi by d theta into d theta by ds. D psi by ds is equals to d theta by ds into 1 plus d phi by d theta. 1 by rho is equals to 1 by ds by 1 d theta into 1 plus d phi by d theta. We can take it as equation 4. Now let's find the ds and ds by d theta and d phi by d theta to get the equation of the radius of curvature. Value of ds by d theta. The above figure indicates the smaller portion of the curve ds with the coordinates as follows. P is equals to r comma theta and q is equals to r plus dr comma theta plus d theta. From the above figure, OP is equals to R, OQ is equals to R plus dr. Angle POQ is equals to d theta, PQ is equals to ds. The line PN indicates the perpendicular drawn to the line OQ from P. From the above figure, Pn is equals to Po, sin d theta is equals to R sin d theta, and NQ is equals to OQ minus ON is equals to R plus dr minus R cos d theta. NQ is equals to R into 1 minus cos d theta plus dr. NQ is equals to R into 2
sin square theta d theta by 2 plus dr. Now from triangle PQN, PQ square is equals to PN square plus NQ square. ds square is equals to r sin d theta whole square plus 2 r sin square d theta divided by 2 plus dr whole square. Divide both sides with d.
ds by d theta whole square is equals to r sin d theta by d theta whole square plus 2 r sin square d theta by 2 by d theta plus dr by d theta into whole square. ds by d theta whole square is equals to r square sin d theta by d theta whole square plus 2r into d theta by 4 into sin d theta by 2 by d theta by 2 whole square plus dr by d theta whole square. Next step, ds by d theta whole square is equals to r square sin d theta by d theta whole square plus r d theta by 2 sin d theta by 2 by d theta by 2 whole square plus dr by d theta whole square. Taking limits on both sides, we get limit d theta limit extends to d theta to 0, ds by d theta whole square is equals to limit extends to d theta to 0 r square into sin d theta by d theta whole square plus limit extends to d theta to 0 or d theta by 2 into sin d theta by 2 by d theta by 2 whole square plus limit extends to d theta limit extends to d theta to 0, ds by d theta whole square is equals to limit extends to d theta to 0 r square into sin d theta by d theta whole square plus limit extends to d theta to 0 or d theta by 2 into sin d theta by 2 by d theta by 2 whole square plus limit extends to d theta to 0 dr by d theta whole square. ds by d theta whole square is equal to r square limit extends to d theta to 0 sin d theta by d theta whole square plus 0 plus dr by d theta whole square. ds by d theta whole square is equal to r square plus dr by d theta whole square. We know that limit extends to d theta to 0 sin d theta by d theta is equal to 1. ds by d theta is equal to root of o square plus dr by d theta whole square. By putting dr by d theta is equals to r1 in the above equation, we get ds by d theta is equals to r square root of o square plus r1 square. Value of d phi by d theta. In Cartesian form, the slope of the tangent is given by slope is equals to dy by dx is equals to d psi. dy by dx is equals to tan t in tan into theta plus phi. dy by dx is equals to tan phi plus tan theta divided by 1 minus tan phi tan theta. In Cartesian form, the x and y coordinates of the point P shown in the above figure can be given by x is equals to o cos theta and y is equals to o sin theta. By differentiating it with respect to theta, we get dx by d theta is equals to d by d theta into o cos theta. And dx by d theta is equals to minus r sin theta plus r1 cos theta, and dy by d theta is equals to d by d theta into r sin theta. Therefore, dy by d theta is equals to o cos theta plus r1 sin theta. The term dy by dx can be also written as dy by dx is equals to dy by d theta by dx by d theta. By putting above the values of dx by d theta and dy by d theta, we get dy by dx is equals to o cos theta plus r1 sin theta divided by minus r sin theta plus r1 cos theta divided by dy by dx is equals to o cos theta plus r1 sin theta divided by minus r sin theta plus r1 cos theta into 1 by r1 cos theta divided by 1 by r1 cos theta. dy by dx is equals to r by r1 plus tan theta divided by minus r by r1 tan theta plus 1. dy by dx is equals to r divided by r1 plus tan theta divided by 1 minus 1 r by r1 into tan theta. This is equation 6. Now compare the right hand sides of the equation 5 and 6. We get tan phi plus tan theta by 1 minus tan phi tan theta is equals to r divided by r1 plus tan theta divided by 1 minus r1 r divided by r. Now compare the right hand side of equation 5 and 6. Tan phi plus tan theta divided by 1 minus tan phi tan theta is equals to r divided by r1 plus tan theta divided by 1 minus r by r1 into tan theta. From the above comparison, we can conclude that tan phi is equals to r divided by r1, phi is equals to tan minus 1 r divided by r1. By differentiating with respect to theta, we get phi by d theta is equals to d by d theta into tan minus 1 r by r1, 1 by 1 plus r divided by r1 square into d by d theta into r by r1. 1 by r1 plus r by r1 whole square into r1 r1 minus r1 into r2 divided by r1 square. r1 square minus r1 by r1 square into 1 plus r by r1 square. d phi by d theta is equals to r1 square minus r2 divided by r1 square plus r2. Now put these values of d phi by d theta and ds by d theta in equation 4 and we get 1 by rho is equals to 1 by ds by d theta into 1 plus d phi by d theta. 1 by rho is equals to 1 by root of r square plus r1 square into 1 plus r1 square minus r2 by r1 square plus r2. 1 by rho is equals to 1 by root of r square minus r1 square into 1 r1 square plus r square plus r1 square minus r2 divided by r1 square plus r2. 1 by rho is equals to 1 by root of r1 square plus r2 into r square plus 2 r1 square minus r2 by r1 square plus r2. 1 by rho is equals to r2 plus r2 r1 square minus r2 divided by r1 square plus r square. Rho is equals to r square plus 2 r1 square minus r2 divided by r1 square plus r2 whole power 3 by 2. And finally we get rho is equals to r square plus r1 square whole power 3 by 2 by r square plus 2 r1 square minus r2. This is the equation of the radius of curvature. This is the equation of the radius of curvature of polar form. Thank you.